Now, the way object-oriented programming or OOP fixes all those issues is by introducing a better design from the start and then building everything else around it. At the heart of OOP, everything can be explained through two things: data and actions related to that data. For example, let's take a door. What data can be described about a door? Things like height, width, color, or how many locks it has. And what actions can be taken on a door? We can open it, close it, paint it, maybe change the locks. Even we can drill holes in it. Everything you can think of can be broken down into a set of data and actions. And as programmers, we get to decide which data and actions are important for our program. Sometimes we'll need more, sometimes fewer would be better. It depends on what we are trying to achieve. Now let's go back to our customer example. What data do we have for customers? Things like name, address, phone number. We already saw some of them on the code that we went over when we were trying to figure out why procedural programming is not good. Like maybe ID number would also help for each customer. What actions can a customer can perform? Things like adding an item to a cart, removing an item from a cart, check to see what's already in the cart, see the total cost of whatever we have in the cart, and get a report of whatever we already purchased. So once we have a list of data and actions, we can create something that is called a blueprint for that customer or for that topic. So as you can see, these are the data that I came up with. We can have more, we can have less. Totally depends on the situation and the programmer. I think a customer needs to have an ID number, name, address, phone number, and list of all the purchases. And here are some methods that I think each customer should be able to do. Adding an item, removing an item from the cart. Is the cart already empty or not? Displaying what is already in the cart. Showing the prices of items that are already added to the cart, and finally buying everything that we have in the cart. And again, we can add more or less, but this is just an example. So now we have all these. We have a single blueprint of whatever a customer should have and all the actions a customer can do. In programming, this blueprint now is called a class. A class encapsulates or bundles the data, which we also call attributes, and the actions, which we also call methods or functions, all in one place. And we use something like this, Unified Modeling Language or UML, to show details of classes. So every time you design a class, you want to kind of detail everything, like what type each of these attributes can be expected to be saved inside them. Like these are the expected types that each one of these attributes can hold. Also, we want to show details, what type of parameters, what type of values, attributes each one of these parameters can hold, and what are the expected types that each one of these methods can return. So we kind of need to mention all the details through this UML. And we always start with explaining the attributes, and then we list all the methods at the end. Again, depending on the situation as a programmer, we may add more attributes or methods or less as needed. Once the class is designed, we can create instances of this class. Okay. And now each instance is what we call an object. So now we are creating an instance from our blueprint, where the blueprint is called a class and each instance from that blueprint is called an object. And each object now is completely independent. That means changing one object has no effect on other objects, and we can create more actually. So whatever now we are holding as a data for this object is going to be completely independent from whatever we are holding for another object. Once we change one of them, has no effect on the other one. And we can create as many objects as we want. So now if we store all these objects inside the list, we can manage an unlimited number of customers here, and all data and actions for each customer stay neatly in one place. So now we have an unlimited number of instances or objects that we created from our class or blueprint, and they're stored all together in one list. So now we are basically each item of this list is going to be one object, and now we have a list of objects, and they are absolutely independent from each other. So once we change one of them, has no effect on the other one. Once we get an information, once we get one of these objects, it has all the data related to that customer in one place for us. This design actually solves all the problems we had with procedural programming. No more repetitive codes, no messy separated list, and everything is easier to maintain all in one place. So to summarize, we use UML to design our class and show all the details. Then we design a class from that UML, and from that class we create objects. In the next video, I'll show you how to actually write a Python code to define an actual class and create objects from it.